Hey guys, welcome back to another video. So in this video, we'll be talking about global and local alignment algorithms under computational biology. So this is a very important topic and this is the most important algorithm that we need to focus on. So let's get started with this. So talking about local alignment, so we'll talk about the gap penalties first before just moving into the algorithm and alignment scores. So talking about the gap penalties, so the inclusion of gaps and gap penalties is necessary to obtain the best possible alignment between the two sequences. Because this is very important that why are gap penalties necessary? So gap penalties are necessary because some sequences undergo mutations and these are not the same as we see. So the inclusion of gaps somewhere in the sequence makes the possible alignment between the two sequences a better one so that we can get a proper alignment score out of the two sequences in a pairwise alignment. So talking about this alignment gap penalty, so this is written as this. So in this Wx is the total gap score, G stands for gap open penalties for any gap, and R stands for gap extension penalty for each element in the gap. So total gap score equals to gap open penalties plus gap extension penalties into X. So big X stands here for the length of gap. So that was for the gap penalties. So moving on with let's talk about the Needleman and Wunsch algorithm for global alignments. So Needleman and Wunsch were the two persons who gave the term global alignment. So these were a very helpful thing so that we can align two sequences properly. And also basically this algorithm is to quantify the similarity between two sequences definitely. And insertion and deletion is rare in comparison to substitution. And it makes more sense to penalize gaps more heavily than mismatch when calculating a similarity score. So this line means that basically we charge or put gaps give gaps a higher score, or like let's take an example, and in that example we just put arbitrary values for mismatch, match and gaps. So gaps and let's say gaps are -1, no, let's say mismatch is -1, match is +1 and gaps are -2. So we are charging gaps heavily in this case, as you can see. So gaps, whenever there's a gap, so we have to deduct -2. Whereas in case of a mismatch, we just have to deduct -1. And in case of match, it's always a plus. Alright, so we in this case, always we generally focus on to penalize gaps more heavily. In general questions also, in case of global alignments, you'll get a gap score which is normally higher or much more than the mismatch and match scores. So moving on with this. So let's say I've taken this and let's take an arbitrary example in this. Let's name it as a match is -1, +1, a match is +1, -1 as a mismatch, and -2 as a gap, as I previously mentioned. Alright, so larger the gap, the more we have to subtract. It is basic, as you can understand. So talking about similarity between the two sequences, so let's take this example straight away. Alright, so as you can see, so let's take these two sequences, just these two sequences, leaving this apart. Alright, so as you can see, these two are a match, as you can see. Also I see here A, and this is a mismatch. Also this is a mismatch. I guess this is a mismatch as well. Also I made a mistake, I guess, somewhere or the other. Let me just okay. Okay, we got it. Okay, so basically I'll teach you this thing. Okay, let me create one more example for you. So let's take this as an example: C, G, A, E, C, A. So this is one sequence, and let's take this is another sequence: C, C, A. This is G. This is C again. This is G. So let me just include one more, and here we'll leave it as a gap. Alright, so let's just find the optimal score for this. Alright, so leaving this apart, we'll just focus on this now. Alright, so there's a fault in this, so that's why I'm leaving this, and they are considering on this. So let's say this, as you can see, this is a match. These two CC is a match. GC is a mismatch. All right, A is a match. This is a mismatch TG, whereas CC is a match. Where this is a mismatch, this is a gap. So how will we calculate the score? As you can see here. So this is pretty simple. Like I'll tell you how. So as you can see, how many matches are there? This is one match. This is two matches. This is three matches. I don't see any matches in this sequence, as you can see also. So let's say matches plus one, right? Plus one into three. All right. So there are three matches, and we multiplied it with the match score. All right. Also, let's see how many mismatches are there in this. So mismatches are, this is now one, this is two, and this is three. So three mismatches as well. So mismatch score is minus one. All right, into three. Again, this is for mismatch, and as I see, there is only one gap. Already, as you can see, the gap score is minus two, and gap number of gaps are one. So let's just count entirely how much is this. This is plus three. All right, this is minus three. This is minus two. All right, so what will be the total? So minus three plus, so plus three minus one is minus three is zero, and minus two is just it. So the score will be minus two. All right, this was minus three, right? So the score is minus two in this case. All right, so this is how we can calculate the optimal alignment score. All right, so this is a simple pattern, but I'll teach you the complex thing, which is the global alignment. So that is a bigger format of this. So if you're given like this, this is how you can do this. Also, the alignment that gives the highest score is the optimal alignment. All right. So which is the highest score? Like if you get more plus sequences, like if you get sequences which are positive value, which are higher than this minus values, right? So definitely, which of the alignment gives the which of the alignment means here is, like in this we are just finding the alignment score through this pattern, and there are other alignment methods such as local alignment, global alignment. So in which of these alignments we find a higher score? Let's say this alignment gives us minus two, whereas in global alignment we get four, whereas in local alignment we get six. So which one will choose? So we'll choose six. This is the highest value. As you can see, the highest score is the optimal alignment. All right. So moving on with this. So this is the technique under which global alignment uh, algorithm takes place. So this is the basic technique under mechanism under which the global alignment works. All right. So this is the basis that I taught you. Listen, like this is same, and in the same way, the global alignment sequences pattern also do have these match, mismatch, and gap scores. So accordingly, we'll calculate the alignment score. But these are pretty much different. Global alignment is pretty much different. In that we have to make a proper matrix, and then we have to calculate the scores. It is not that it is not as simple as this. As you can see, you just have to find matches and mismatches as well as gaps in this, whereas you have to calculate every point of the matrix, and then you will get the optimal score. So moving on with this. So talk about this in one alignment to occurring matrix where sequence S of length m is written on the x-axis and t of length is written on the y-axis. So these are some of the algebraic terms you'll get to see everywhere. So these are not of much importance, and I assure you that these won't come in your exams as well. So I've just provided these things just for informative, providing you as much as information about this. All right, so all possible alignments of S and T are contained in array this of A00 represents a gap at the beginning of each sequence. Also, the optimal alignment will be the path through the array has the highest score. All right, so moving on with this, these are basic informative terms. So you can just give it a read if you want. All right, so talking about this, if we want to calculate the score at any point position, like such as AJ in the alignment A, we only have to look at the adjacent three adjacent cells in the matrix to calculate that score. So this is where the mechanism of global alignment comes. I don't think you would be able to understand through this, so I'll be explaining through a matrix where you can properly understand like how these three adjacent cells through like how looking at three adjacent cells we can calculate in a matrix. All right, so for these algebraic terms you can just remember this may come in exams. So this is through it is represented like this. All right, so aj like a minus a, j minus 1, I minus 1, j minus 1, I minus 1, j. All right, so there these are the positions just prior to aj at which either a gap penalty is -2 and mismatch is +1 or -2 and gap penalty was subtracted for instruction. So last point is not much of importance, so you can just leave this point. Otherwise these 2 points are pretty much similar as I've said you. So this thing you have to remember, like talking about global alignment. So this is the one that you need to remember for global alignment. So this is the calculation of alignment matrix. So this is if you are told to like write the matrix for global alignment. So this is what you have to write. So this is the thing you have to just write. Aj equals to, leave this part, then in brackets a I j minus 1, or close the brackets, -2, also a I minus 1 j minus 1, comma plus pij, also a I minus 1 j minus 2. So this is all you have to write. And just one more very important thing in global element, also in local element, is the backtracking the element. All right, so backtracking plays a very important role while you are considering global and local alignment, through which you can find the optimal score. So let's just keep this video till here. I'll be explaining the further parts in my next video. So thank you for watching this video. Stay tuned for more.